In this video lesson, we'll be discussing atomic structure, protons, neutrons, electrons, where they're located, how to determine the number of those things in both regular atoms, ions, and in isotopes. So let's get started. So first thing we need to talk about are the subatomic particles that make up an atom. So you can see up here above that we have the proton, we have the neutron, and the electron. So most of you have probably heard about these things, but just in case you haven't, we're going to kind of refresh and review. So first thing first, the proton. So the protons, they have a positive charge. They're a positive charge, and you can kind of see that up here. So with the laser pointer, you can kind of see that there's that positive charge on a proton. And protons are located in the nucleus, or kind of the center area of the atom. Now, moving on to neutrons. So neutrons, they have no charge, or they are electrically neutral. And they are also located in the nucleus with the protons. And finally, we have the electrons, which they are the particles with a negative charge, and they are located in orbitals around the nucleus. So we have the proton, we have the neutron that are in the nucleus, and then we have the electrons kind of orbiting around on the outside. And one other thing I want to point out is, if we take a look here, so we have the proton and the neutron. You can kind of see that they're generally the same size. So the proton and the neutron are generally the same size in the nucleus. And then we have the electrons here, which are much smaller. Now, these aren't their actual sizes, but you can just see, generally speaking, the protons and neutrons are much larger than the electron here. Now, let's kind of get a better look at that. You can kind of see here, again, we have the protons and the neutrons in the nucleus here. So we have those kind of in the center of the atom. And then around the outside, depending on the atom itself, we have these electrons that will orbit around the nucleus where the protons and neutrons are. So we have the nucleus here in the center, made up of proton and neutrons, and then we have the electrons that orbit around the outside. So now that we kind of know how an atom is arranged, what things are in the atom, we're going to kind of talk about how we can count up and determine how many of those subatomic particles, the protons, the neutrons, and electrons, that there are. And we need to just go over some of that notation and what we're going to look at when we're looking at chemicals. So here we have the chemical symbol for silicon. So first off, what we have, we obviously, hang on, let me use the actual, we will have the element symbol. So usually 1 to 2 letters for the element's symbol. And then we would also have the element's name written somewhere around it. So we have the symbol, we have the name. Typically they kind of look similar, like we have the SI from silicon coming in. But other times, just depending on what letters we've had been used, that doesn't always work out. Now, this first number here, which is typically a whole number, and let me get the laser pointer again. So, actually, I'll use the lightsaber this time. So, the 14 right there, that 14. So, that number right there, that is what is referred to as the atomic number. Typically, it is a whole number, and it represents the number of protons in the nucleus. So, the number of protons in the nucleus. That tells me what element I'm going to have, and it tells me the atomic number of the element that I'm looking at. Now, this other number here that's usually with the notation, again, I'll use the zero right there. That number, which is typically a decimal, it may be a whole number, as far as this could be 28.00, but there's always going to be kind of a decimal with it. And when that happens, that was what's referred to, hang on, that's not what I wanted to do. We look at that number, which is the atomic mass, and that tells me how many protons and neutrons are in the nucleus. So typically, the second number is a bigger number, and it's also a decimal when we look at it. So the number of protons and neutrons in the nucleus when we look at those two things. All right, now let's say we look at oxygen. So talking about those numbers that we were looking at before, let's determine the number of protons, neutrons, and the number of electrons. So, for example, here we go. Number of protons. Well, we can determine that from the atomic number here. So that number is always going to be the number of protons. So we're going to have 8 protons. Now, the number of neutrons, remember that this number here, this number right here, the 15.99, that's my atomic mass, which represents the number of protons and neutrons. Now, I'm going to round this up to 16 just to make my math easier. So, because we can't have half numbers or smaller numbers of neutrons. So when we look at that, I'm going to also have 8 neutrons, because I need a total of 16 electrons and protons and neutrons in the nucleus. So I already have 8 protons, so I have to have 8 neutrons for a total of 16. And then all elements typically are stable, or they are neutral, so they will have no positive or negative charge. So therefore I also have 8 electrons, because I need these two. I need the protons, and I need the electrons. So the protons here, electrons here to balance out for a net charge of 0. Okay, so let's look at more examples. So let's look at fluorine. So again, starting with fluorine. So this 9 here, that's going to tell me how many protons I have. So I have 9 protons because my atomic number represents the number of protons. So that also tells me I'm going to have 9 electrons because I need to be a stable atom. Now, number of neutrons, again, we get from this number 19 right here. So 19, I have 19 protons and neutrons total in my nucleus. I know 9 of those are protons, so the other 10 have to be neutrons. So starting from number of protons with the atomic number here, so this number tells me the number of protons. Number of protons tells me the number of electrons I'm going to have. And then from there, this 19, I have to have a total of 19 protons and neutrons. So therefore, I have already used 9. I have to have 10 neutrons to make that 19. Now, just as I said that most atoms like to be neutral, so no positive or negative charge, there are atoms that do have positive and negative charge, and we call those ions. So an ion is an atom that has a positive or negative charge due to a gain or loss of electrons. That's it. They have to gain or lose electrons. They don't lose protons. They only lose or gain electrons. So that number of protons is always just going to tell you what element you are dealing with. That's never going to change. So if we change the number of protons, we change the element, and that's not what we want to do. We're only going to change the number of electrons. So once we have the ion we're looking at, we can determine everything as we do with a regular atom. Now, the notation looks a little different. So when we have an ion notation, we're typically going to have the element's symbol. So this is chlorine, its symbol Cl. And we're going to have the charge. Is it positive, negative, and how positive or negative is it? So for example, this chlorine has a charge of -1. Now, if we pull up the actual chemical symbol, we know chlorine, the fact that it's chlorine tells me that I will have 17 protons. So that number is always going to be the same, no matter what. I can only have 17 protons, otherwise it's not chlorine. So I know that right off the top. Now, I'm going to jump to neutrons for now. So again, remember this is this number here The 35.545 is our atomic mass, which tells me number of protons and neutrons. I'm going to round that down to 35, which tells me I have to have 18 neutrons still. I have to have 18 neutrons. Then, with my electrons, remember, I have an ion now, so I'm going to have a different number of electrons than I do protons. And since I have a negative 1 charge, I need to have one more electron than I do protons. Otherwise, I don't have that negative 1 charge. So 17 protons, because the atomic number of chlorine is 17. That tells me the number of protons. 18 neutrons, because I need 35 for my atomic mass. And there are 18 electrons, because I need one more electron than I do protons to get this negative 1 charge here. Now looking at another example. So now we have sodium, but now we have a +1 charge on the sodium. So again, starting with the chemical symbol from the periodic table, I know that I'm going to have 11 protons in the nucleus, because that's what makes it sodium. That's what I have to have. Now, number of neutrons, remember, based on the atomic mass. So we're going to round that to 23. So therefore, I need 12 neutrons with the 11 protons. Gives me 23 total. And now my number of electrons, again, needs to be different than the number of protons, because I have an ion here. So now this time my sodium has a positive charge, +1. So therefore I need to have more protons than I do electrons. So I'm going to have only 10 electrons in this sodium. I do not change this number here. I do not change this number here, because that's going to change the element. I can only change the number of electrons when it comes to ions. That's the only thing that I can change. And looking at one more example, so I have calcium this time. So starting with calcium's chemical symbol from the periodic table, I know I have to have 20 protons, because that's its atomic number. That's what makes it calcium. Now the number of neutrons, I'll keep that number at 40 right here. So keep that number and round it to 40. So therefore I have to have 20 neutrons for a total of 40 protons and 40 neutrons. And this time the calcium has a +2 charge, and I can only change my electrons, so I need to have less electrons than I do protons, because I need a positive charge, and this time it's 2 less. So I only have 18 electrons. Again, I cannot change this number here, because that changes the element. If I made that 18, I would be dealing with a completely different element, and that's not what I want. I still want calcium, I just want it to have a +2 charge, so I'd take 2 electrons away from it to make 18. And the last thing that we're going to look at are isotopes. So isotopes is an atom that has more or less neutrons than it usually would, based on the number from the periodic table. There are typically several versions of an element or an atom, which is all based on stability. So some atoms are more stable if they have more neutrons, some are stable when they have the same number of neutrons as they do protons, and it just all depends on its stability. Smaller atoms typically have about the same number of protons and neutrons, and larger elements usually have more neutrons than they do protons. Just a generality that we look at. Now, looking at the notation and talking again about counting these protons, neutrons, and electrons. So, carbon, 14. So what we have here, we have the name written, so it looks a little different than the ion and the atom. So we have the name written here, so we have carbon, right? So we know we're talking about carbon. this number here is our atomic mass we're going to be using. So remember, atomic mass is the number of protons and neutrons in the nucleus. And if you look at carbon's chemical symbol, you can see that these two numbers here are different, right? So that 12, which is on the periodic table, is not the same as this 14. But right now we're talking about this carbon has 2 extra protons, or 2 extra neutrons in it. We've added 2 neutrons. So we know from our previous discussions that I have to have 6 protons. I'm going to write this actually shorthand. So P plus, so 6 protons, because protons have a positive charge. And that comes again from here, because if it's not 6, it's not carbon. Now, again, we're not worried about this number. We are focused on this one here. This is our mass number that we're worried about, because we're looking at a different version of carbon. So therefore, I need 14 protons and neutrons. I already have 6 protons, so I have to have 8 neutrons. We just use the letter N because it's neutral, so it can just be neutron. N for neutron. And finally, these isotopes are stable just like a regular atom, so therefore their electrons will be the same number as the protons. The only thing we're changing in the case of isotopes is the neutrons, so we just have different, which doesn't change the charge at all. Now looking at another example, so we have sodium, which sodium has, so we're looking at sodium 24. So again, the name here, this is our atomic mass we're going to be dealing with. So sodium, we know, has 11 protons because its atomic number is 11. If it didn't have 11, as we know, it wouldn't be sodium. So we can say with isotopes, we also have 11 electrons because they're going to be stable or imbalanced. And again, we're looking at this new atomic mass, so we're going to ignore the 22, or in this case 23. So I need 24 protons and neutrons in the nucleus total. I already have 11 protons, so I'm going to need 13 neutrons in my nucleus. And one more example here. So here I have xenon 133. Xenon's a bigger element. So we know we have to have 54 protons. I would also then need 54 electrons. And so again, I'm not worried about this 131 number here. I'm focusing on the 133 right here. So 54 protons, I need a total of 133 protons and neutrons. Doing that math would give me 79 neutrons. So 133 minus 54 would be 79 neutrons. So you can see here, this is one of those bigger elements, so we have more neutrons than we do protons, which is just, again, that generality that we spoke of.